In this example, we are going to talk about circular uniform motion. What we mean by circular uniform motion, the object is moving with constant speed when it's making circles. The speed is constant, is given by 2 pi r over t. R is the radius of the circle, and t is the time it takes to the object to make a complete circle, and is measured in seconds. So when the object is making circular uniform motion, we said the velocity is changing. The velocity is the magnitude and direction. The magnitude, which is the speed, and direction is the direction of velocity. Let's say if the object is at this point, its velocity is tangent to the circle and is in that direction. If the object is going down, velocity will be in that direction. But remember, the speed is constant. It will be given by 2 pi r over t. And acceleration is centripetal, is pointing toward the center of the circle. So, and is given by v squared over r. The v is the speed of the object, and r is the radius of the object. So, when we have circular uniform motion, the speed is constant. The velocity is changing. Remember, the velocity is the speed and the direction. If the direction is changing, even the speed is constant, then the velocity is changing. Omega, which is the angular speed, omega is given by 2 pi over t and is in radian per second. You can see sometimes omega in RPMs. R means revolution, P means per, division, M means minute. Remember, in one revolution is 2 pi radian, and 1 minute is 60 seconds. So if we want to bring the RPMs to radian per second, we need to convert revolutions to radians and minute to seconds. Now, we have this, we call it angular speed. Remember, when the object is making circle, is moving certain distance, and also is making circles. These circles are measured or in radian per second. So there is two kinds of velocities. This we call it angular velocity. Omega is angular velocity. Linear velocity v is r omega. So remember, to go from linear to angular, we multiply by r. And you must bring omega to radians per second in order to get the meters per second. The linear velocity v, this v, is in meters per second. So in order to get meter per second, you have to make sure omega is in radian per second. So when you multiply meters times radian per second, it gives you meters per second. But if you keep omega in RPMs, the answer to the speed will be wrong. So make sure omega is in radian per second, and so you can get the speed in meters per second. Of course, the r, which is the radius, has to be in meters, because meters times radian per second is meters per second. If the acceleration is centripetal, means toward the center, we say the acceleration is centripetal toward the center, and the net force also is centripetal. It will be all the time facing toward the center. So if the object is at this point, the force will be toward the center. If the object at this position, the acceleration will be centripetal, and the force also will be centripetal. Now, the definition of the force using Newton's law is the mass times acceleration. This acceleration is centripetal. We call it also radial, means toward the center. The net force applied on this object will be the mass of the object times the square of the speed divided by the radius of the circle. The radius of the circle is r. So the net force is the mass times acceleration, and this force is centripetal also. Let's do this example to find the acceleration of the object. So we have an object or a ball of 0.2 kilograms is at the end of the string and is revolving uniformly in a horizontal circle of radius 0.5 meters. The ball makes 3 revolutions in second. The question is to find the centripetal acceleration of this ball. Now, we know by definition the centripetal acceleration is given by the square of the speed over the radius. And also the angular velocity should be in radians per second. In this case, we have the angular velocity in revolutions, 3 revolutions per second. Remember, in 1 revolution, we have 2 pi radians. So 1 revolution or 1 rotation for 360 degrees is the same thing, is 2 pi radians. V is the linear speed, is radius times the angular speed. So in order to find this linear speed, omega has to be in radians per second, and the radius has to be in meters, because meters times radian is meter, and the linear velocity by definition should be in meters per second. So let's find omega in radians per second. We said omega is 3 revolutions, 3 times 2 pi radians. This revolution is replacing 2 pi radians per second. So omega will be 6 pi radians per second. So we found omega. Now let's put omega here. Said omega is 6 pi radians per second. We need to find linear speed. We said the linear speed by definition is r omega. Now we can bring the acceleration here. We said the acceleration is v squared, which is r omega squared over r. It will be just r omega squared. So r is half a meter. Omega is 6 pi radian per second squared. And then the centripetal acceleration should be 177.65 meters per second squared.